Hello, in this video I describe how I crudely measured the radius of the Earth. The value I got was 5,925 kilometers, which is pretty close to the accepted value 6,371 kilometers. I'm not doing professional surveying or anything. So the way I did this was by observing a target from a high elevation and then observing that from a low elevation it was obstructed. Then I put the two together, and that gives a range on the radius of the Earth. So I'll go over everything here, but you can pause and read it if you want. So now I'd better get, or the accepted value of Earth's radius better be in the range I get, or the globe model is going to be in trouble. So now here are the observations. There's one pair of observations. So I guess here's from the low elevation, so you can clearly see, all you see right here, there is an island in this direction, but all you see is sky. And then of course you got to repeat your observation, so I repeated it on a different day, and again all you see here is sky. There's no landmass here. That's from the low observations. Now from the high observations we see this. We see the landmass. So basically all I did was just change my elevation to 170 meters instead of from sea level. So you can see the landmass right here. And then, of course, you got to repeat your observations. So here's the same thing on a different day. You see the landmass. So that's what it looks like. One thing I need to address is atmospheric refraction. It ultimately turns out I can just ignore refraction, and I'll just briefly explain why. So we know in a standard atmosphere, light bends down. Therefore, if you go out and look and see something fully obstructed, like, for example, here, there's an island here, but it's obstructed. There's landmass here, but it's obstructed. Then if you could snap your fingers and remove the atmosphere, the object, which is down here, would sink down even further. So now what about from the high vantage point? Is looming bringing an otherwise totally hidden target into view? No. I did a very crude analysis to show why. I need to know the height of the edge of Bell Island for this. I estimate it to be about 60 meters from Google Earth, but it's probably higher. But 60 meters is near the worst possible case. But even using 60 meters, I predict that without refraction, I would still see some of the target. You can pause and go through this if you want. So in both cases here, the low observation and the high observation, if I could snap my fingers and make the refraction go away and see in straight lines, the resultant data I'd be taking from the observations would be the same. So now let's finally use that data and get a range for the Earth's radius. So I need to explain what I'm doing here. So this is a sphere with a line of sight and a target. So as you decrease, so you see here, you can see like the target from halfway up. But if you decrease the size of the sphere, keeping everything the same, you'd only be able to see the tip of it. And if you decrease the sphere even more, you'd not be able to see any of it at all. So this is how changing the radius changes the hidden height, or the obstruction height, or whatever you want to call it. So the idea is for each of the observations to find the range of possible radii. So first let's use the obstruction observation. So we'll use this observation here. So I'll go to my curve calculator, and this is basically the two numbers you input are the observer height and the distance to the object, and the output you get is the amount hidden below the horizon. So here's like the graphic here that just shows, like, you put in x and the arc length, m plus n, and you get out y. Okay, so we're using the low elevation observation, the obstruction observation, and we need to take only the values that predict full obstruction, which is what we saw. So we plug in an elevation of 4.5 meters and a distance of 61,550 meters, and then we find all consistent radius values. So I got the radius cell here is attached to this slider. I can change the radius. So we start from 0 meters. That's a consistent radius, and we increase the radius until we predict an obstruction of less than 155 meters, which would mean the target would be visible. And then, so we just watch the blue cell there, and as I change the radius, and right at about 8.9 million meters, we get an obstruction of 155 meters, and anything higher than that, we would predict the target being visible. So our range that we get from there is between 0 and 8.9 million meters. So now we're going to use the observation with the target visible. We need only the radius values that predict instead this time partial or full visibility. So we plug in the data from this observation here. Viewer elevation 170 meters and distance of 61960. So this time we want obviously an infinite radius predicts no obstruction, and then we shrink the radius until the target is predicted to be fully obstructed, which would contradict the observation. So you see I'm shrinking the radius here, shrinking on 8.9 million meters, 8 million meters, and all the way down to 2.9 million meters, and that's where we predict, that's right about where 155 obstruction happens. And then anything less than that would predict that the whole target would be obstructed, and that would contradict the observation. So the radius is between 2.9 million meters and infinity meters, according to this observation. Now we put the two ranges together. So this is from the low elevation observation, this is from the high elevation observation, and obviously the possible values is the intersection of both ranges. So we get that the Earth's radius is between 2.95 million meters and 8.9 million meters. You can average that to get 5,925 kilometers, with the error being 2,975 kilometers above and below. So basically the final result is that Earth's radius is about 6,000 kilometers plus or minus 3,000 kilometers. The accepted value 6,371 kilometers is easily in that range. So we did not contradict the globe model. All is good, but however we contradicted the flat Earth. So, flat earthers, please tell me what the heck is going on here. How does my measurement fit with the Earth being flat?